So a proportional relationship looks like a couple different things. So if we have a table, we're looking for something scalable. So when I say proportional, I want you to think scalable. Meaning if we double the x's, the y should also double. And if we're looking in a graph, we're looking for a line that goes through 0, 0. It's got to have both parts. If it's an equation, we're looking for an equation like y equals rx, where r would be the unit rate, or we call that the constant of proportionality. So let's look at some examples. So the first one we have here is a line that goes through 0, 0. So that one has to be proportional. It's got both. Here's our table. First thing I can see in the table is there's no 0, 0. So if there's no 0, 0, it cannot be proportional. Simple as that. Let's see also why that works. Why it doesn't work is x and y coordinates. So if we're looking at like 3 to 6, goes from 2 to 1. So 3 to 6 is doubling. This is not doubling in the same direction. No, it's being halved, or a -1 pattern. If you go from 3 to 12, 12 is at -1. That should be times 4. This is certainly not times 4. So that one you can clearly tell is not proportional. Let's look at this one. Much bigger table here. So again, we don't see 0, 0, so we know it's not going to be. Let's show it a different way though. So 0 is 4, 1 is 8, 2 is 16. So from 1 to 2, that's doubling. 8 to 16, oh look, that is doubling. That looks like that might work. But look what happens if we go further in the table. Let's go 2 to 4. 2 to 4 is doubling. 4 is 64. That's not doubling. So that can't work. So that's why this one doesn't work, because it has no 0, 0. And as you can tell, it's not scalable here, which is why that one's not proportional. This equation, y equals 2.14x, that is proportional. And our unit rate, or constant of proportionality, is the 2.14. This one we can see not a line, so not proportional. This one, let's say, goes through 0, -4. Again, we can look at our table from 4 to 8 here, from 3 to 10 for x and y coordinates. This is doubling. This is not doubling, so you can tell it doesn't work. Let's look at another reason the table y doesn't work. If you divide your y's by x's, they have to be the same rate. So like if we take, let's see this, just pick any 2 points really, 9, -10, and 12, -16. If I take -10 divided by 9 and -16 divided by 12, if it's proportional, they would be the same. So if we do -10 divided by 9, and then we do -16 divided by 12, you'll see different things. This is -1.1 repeated, and those obviously don't match. This is -1 1/3, not the same. Hopefully we can get one here that is proportional. There's a graph that's proportional. It's going down, but it's still a line that goes through 0, 0, so that's proportional. This one again does not have 0, 0, so we can tell that one's not proportional. This equation has the plus 11. If it was just 8.25w, that would be proportional, but the plus 11 makes it not, because it's not going to start at 0, 0. Here we go. I see a 0, 0, so that's a good sign. Maybe this is going to work here. So we have our 0, 0. It's not everything, though. We have to check more than just the 0, 0. So let's check 10, 20, 30. So we're looking again to see a couple different things. So let me show you the thing I showed you before, y divided by x. Let's take our -6 divided by 10, and let's take our -12 divided by 20. If these have the same thing, the same value, then we should have a proportional relationship. So -6/10 should not be surprising that we get -6/10. And then -12/20, again, hopefully you notice that that's the same thing if you simplify the fraction. So these two match, which tells us that if we double here, this doubles. If we triple here from 10 to 30, you'll notice this tripling. So this one is a yes. This one is proportional, and you can check it both different ways there. This equation has an x squared in it. Anything with an x squared in it is not going to work. If it was like p equals 3x, that would be good. but the x squared is not going to be a line, so it's not going to be proportional. This one again, not proportional. This one's kind of interesting. We don't see the 0, 0. We don't see where x is 0. So we have to just do some other work to figure this one out. I like looking at the scaling here. This is times 3. This is times 3. So that tells us, yes, this is going to work. We can again use division though, and we can show it that way. If I do 27 divided by 15 and I do 9 divided by 5, they're both equal to 1.8. Because these things, again, have that scaling of times 3, so they're equivalent fractions. This one would not be because of the plus 1. Let's go to this one. You can tell for this one it's not going to be because of the 0, 4. But this one's also not going to have any scaling that works as well. So 20, 100. This is times 5, and this is times 5. So we have actually multiplication happening, and this is obviously just times 2. So it's not the same scaling, so that's again not proportional. That one would be proportional going through 0, 0. Let's see if we can get one that's trickier. Here we go. I see a 0, 0, which doesn't necessarily mean it's proportional, so we got to double check. We have the 0, 0, which is good, and then 2, 4, let's see, 10, 20. So I'm going to do, let's see, this would be doubling. This would be doubling, so that's a good start. 6 and 30, this is tripling, this is tripling. So that looks good. That is proportional. This one would not be because of the plus 1, and this one is also not going to work because this one does not go through 0, 0, and is also not a constant rate. It's not going to be changing by the same amount. If we look at the table here, 110, 250, 50 over 2, if we're doing the y divided by the x, would be 25, and then 10 divided by 1 is 10. So very different. So that's how you can tell from a table, a graph, and an equation if a relationship is proportional.